Greetings, programs. Welcome to Rationality from AI to Zombies, Chapter 37. Say Not, Complexity. Once upon a time. This is the story from when I first met Marcello, with whom I would later work for a year on AI theory. But at this point, I had not yet accepted him as my apprentice. I knew that he competed at the national level in mathematical and computing Olympiads, which sufficed to attract my attention for a closer look. But I did not know yet if he could learn to think about AI. I asked Marcello to say how he thought an AI might discover how to solve a Rubik's Cube. Not in a pre-programmed way, which is trivial, rather how the AI itself might figure out the laws of the Rubik universe and reason out how to exploit them. How would an AI invent for itself the concept of an operator or macro, which is the key to solving the Rubik's Cube? At some point in this discussion, Marcello said, "Well, I think the AI needs complexity to do X and complexity to do Y." And I said, "Don't say complexity." Marcello said, "Why not?" I said, "Complexity should never be a goal in itself. You may need to use a particular algorithm that adds some amount of complexity, but complexity for the sake of complexity just makes things harder." I was thinking of all the people whom I had heard advocating that the internet would wake up and become an AI when it was sufficiently complex. But Marcello said, "But there's got to be some amount of complexity that does it." I closed my eyes briefly and tried to think how to explain it all in words. To me, saying complexity simply felt like the wrong move in the AI dance. No one can think fast enough to deliberate in words about each sentence of their stream of consciousness, for that would require an infinite recursion. We think in words, but our stream of consciousness is steered below the level of words, by the trained-in remnants of past insights and harsh experience. I said, "Did you read a technical explanation of technical explanation?" "Yes," said Marcello. "Okay," I said. "Saying complexity doesn't concentrate your probability mass." "Oh," Marcello said. "Like emergence, huh? So now I've got to think about how X might actually happen." That was when I thought to myself, maybe this one is teachable. Complexity is not a useless concept. It has mathematical definitions attached to it, such as Kolmogorov complexity and Vapnik-Chergaventis complexity. On an intuitive level, complexity is often worth thinking about. You have to judge the complexity of a hypothesis and decide if it's too complicated given the supporting evidence, or look at a design and try to make it simpler. But concepts are not useful or useless in and of themselves. Only usages are correct or incorrect. In the step Marcello was trying to take in the dance, he was trying to explain something for free, to get something for nothing. It is an extremely common misstep, at least in my field. You can join a discussion on artificial general intelligence and watch people doing the same thing left and right, over and over again, constantly skipping over things they don't understand, without realizing what it is that they're doing. In an eye blink, it happens. Putting a non-controlling causal node behind something mysterious. A causal node that feels like an explanation, but isn't. The mistake takes place below the level of words. It requires no special character flaw. It is how human beings think by default, how they have thought since the ancient times. What you must avoid is skipping over the mysterious part. You must linger at the mystery to confront it directly. There are many words that can skip over mysteries, and some of them would be legitimate in other contexts. Complexity, for example. But the essential mistake is that skip over, regardless of what causal node goes behind it. The skip over is not a thought, but a micro-thought. You have to pay close attention to catch yourself at it, and then you train yourself to avoid skipping. It will become a matter of instinct, not verbal reasoning. You have to feel which parts of your map are still blank, and more importantly, pay attention to that feeling. I suspect that in academia, there is a huge pressure to sweep problems under the rug so that you can present a paper with the appearance of completeness. you'll get more kudos for a seemingly complete model that includes some emergent phenomena, versus an explicitly incomplete map where the label says, "I got no clue how this part works," or "then a miracle occurs." A journal might not even accept the latter paper, since who knows but that the unknown steps are really where anything interesting happens. And yes, it sometimes happens that all the non-magical parts of your map turn out also to be non-important. That's the price you sometimes pay for entering into terra incognita and trying to solve problems incrementally. But that makes it more important to know you aren't finished yet. Mostly, people don't dare to enter terra incognita at all, for the deadly fear of wasting their time. And if you're working on a revolutionary AI startup, there is even huger pressure to sweep problems under the rug. Or you will have to admit to yourself that you don't know how to build an AI yet, and your current life plans will come crashing down in ruins around your ears. But perhaps I am over-explaining, since skip over happens by default in humans. If you're looking for example, just watch people discussing religion or philosophy or spirituality or any science in which they are not professionally trained. Marcello and I developed a convention in our AI work. When we ran into something we didn't understand, which was often, we would say magic, as in X magically does Y, to remind ourselves that here was an unsolved problem, a gap in our understanding. It is far better to say magic than complexity or emergence. The latter words create an illusion of understanding. Wiser to say magic and leave yourself a placeholder, a reminder of work you will have to do later. Here ends Chapter 37. Now for my thoughts. Well, for the most part, this is a follow-on from the previous chapter, a way of rounding it out or telling a story, or just ramming the point home in another way, in the hopes that you'll get it if the previous one wasn't particularly clear. However, I have encountered this myself. If, for example, you are trying to explain basic engineering principles or programming principles to somebody who's otherwise unfamiliar with them, you will get a beautiful and clear example of what Eliezer was talking about here. There will be an automatic assumption on the part of the person, or at least there likely will be. I've done this a few times and it's pretty well universal, that on some level they think they're dealing with a human, with human levels of cognition. So they can just say, "Hey robot, go over there," and that's all they need to do, or pick up the round thing, without realizing all the incredibly complicated things that have to go into that, like, for example, teaching a robot what round means, and then teaching it how to pick up, and then teaching it how to move, and all those incredibly basic, base-level things. And if you're not a programmer, if you're not an engineer, if you're not a person who's had some kind of either training or life experiences that teach them that you must break a complex task down into its most basic parts, unless you've done that, there is just the assumption that you're just going to do the high-level thing and say, "do the thing," without realizing that you're not dealing with a person. You can say to a person, assuming you speak a language, "Hey, go do the thing," and they will figure out what you meant by that and then make their best stab at doing it. You can't do that with a computer. And you can't do that when you're trying to look at base level, how does the supposed AI think, either. To be honest, I found it quite surprising, because I had, I guess on some level, absorbed that any simple-looking task is composed out of multiple simple individual components of task. Cut down the tree seems like a simple task if you're dealing with somebody who already knows how to cut down a tree. But if you don't, then you have to tell them you're going to need tools. You're going to need protective equipment. You're going to need rope and clamps and such. You're going to need to clear the shrubbery out from around the tree so you've got space to work. You're going to have to check to make sure that whichever way the tree goes, it's not going to crush something. You're going to have to make sure it doesn't go bouncing down the hill onto the road and kill some passers-by. There's a whole load of simple basic tasks, all contained within just go cut down a tree. And nothing will hammer that home better than trying to explain it to somebody who's never done it before. And you will see that often they will just skip right over all those details. That's great, they're a human being. But if you're dealing with programming, there is no human being there. There is no thought. You have to do all that the hard way. Every single step. Get an axe. Get a chainsaw. What is an axe? What is a chainsaw? How will you know you've got one? All of those little bits. And in the case of humans, the "and then a miracle happens" moment is somebody else uses their brain to take a stab at figuring out what it is you meant. Frankly, it's amazing we can talk to each other at all. Anyway, that's all for Chapter 37. Tune in next time for Chapter 38. Positive Bias. Look into the dark. Bye for now.